Okay. Good day, everyone. It's Alan Schimmel, DevOps.com, Security Boulevard, Container Journal. Welcome to another great webinar. Today's webinar is filtering internet-bound VPC traffic. We're going to learn why your NAT gateway may not be up to the task. Our webinar today is sponsored by our good friends at Aviatrix. If I mispronounce, I apologize. Before we get started, though, just a little bit of housekeeping. We do use the GoToWebinar control panel here at DevOps.com. And so for that means for most of you, in your upper right-hand corner, you'll see your GoToWebinar control panel. A couple of areas I want to call to your attention. Number one is the section marked questions. If you will make that arrow down facing or caret face down, you'll see it expands. And you can type your questions in there. What's great about this is you no longer have to wait till the end of the webinar to ask your question. You can ask your question as it pops into your head while our panelists are speaking. The section will keep a record of your question. We'll be able to answer it. We'll be able to queue it and get to it at the appropriate time. And if for some reason we couldn't answer it live on webinar, we're able to get to you in writing with an email or other communication later to make sure you get your questions answered. And some of them we could even answer in real time, right? Let me also answer the first question we always get, which is this being recorded, or is this being recorded and will the slides be available? And the answer to both of those is yes. They'll both be up on DevOps.com as well as YouTube, probably within a couple of hours after today's webinar. Secondly, I wanted to call your attention down to the chat window, which is down on the bottom. Here on our webinars, we use chat for technical help. If you have a question about the content or of the speaker, use the question section. If for some reason your audio is not working, slides aren't advancing, or something else is not working, but you can still get to that chat window, we do have engineers standing by there to help you with your problem and try to make sure you get the best experience possible out of our webinar. So with that being said, let us now move over to our webinar today. As I mentioned, it's sponsored by Aviatrix, and today's webinar is features Joe Conwell, Cloud Solutions Architect. Joe, are you there?
Yes, I am.
Okay, and you know what, guys, I was listening to the dry run and the lead up to this, and I think we're lucky to have Joe today. He's going to give you a real architect's engineering kind of view of this. So strap on and I think get ready for a great one. Joseph, I'm going to turn it over to you.
All right, thank you, Alan.
All righty.
Good day, everybody. Pleasure to have you guys join us today to discuss filtering internet-bound VPC traffic. Just a little bit about myself. I am a cloud solutions architect for Aviatrix. I've been in the IT field for about 30 years. From that, I've worked at various companies doing architecture and design and implementation around the globe for states, large government organizations, large financial institutions, and let's see, what else about me? I don't like talking about myself. So I spend a lot of time dealing with customers that, listening to their pain points and trying to build solutions. That's really my background and what I enjoy doing. So today we're going to cover basically VPC policy-based egress or policy-based routing and how to get outside to the internet. We're going to go over a quick background, kind of why you do this, what it's required, what are some of the security requirements that we're going to do for egress traffic and policy-based routing to get outside. We're going to give you a demo of the Aviatrix product, and then we'll open it up to do question and answer. So without further ado, we shall march forward. So for those of you that do not know who we are, Aviatrix is a software-defined cloud routing company. We are the emerging leader in the Amazon space. With that, we carry the Amazon Network Competency Stamp. And our CTO and founder, Sherry Way's mission statement when she built this company was to make cloud networking basically as simple as your dynamic compute and storage that you get from your cloud providers. We are headquartered in California. We have probably some of the best technical support that you can get from organizations. So let's just continue to power on. So Amazon, for most of you, you may have worked in the environment, you may be new to the cloud. Amazon is a shared security model. You have shared responsibility when you go into the cloud. Their securities, their platform, they handle all of that, their personnel, making sure that, you know, strangers just don't walk into the building and can cut cables. That is their responsibility for their platform. The blue section that we have up top is literally what you're responsible for in the cloud and things that you have to think about. That's securing your data. Where's it going to go? What type of platforms am I going to use? Who's going to be able to access my accounts? Who's going to be able to provision things? How do I secure my environment? You know, like you do on-prem, you have firewalls and other constraints that allow you to monitor and secure the infrastructure. You have to do those same things in the cloud. That's your responsibility. So we're going to cover basically some network security items. There's 5 areas that most people have to deal with when entering the cloud. We're going to touch on the top 4. The 5th item that we will go over is actually the main topic here for today, and that's going to be getting out to the internet from your VPC. So the first thing we look at is on-premise to VPC. So when you look at connecting a data center, most companies are in a hybrid state today. They don't just throw things in the cloud. There's still stuff that's on-prem. How do I get connectivity? That's your on-premise to VPC. We also look at VPC to VPC traffic. How do we define and secure access between VPCs? Is it something that you want peered, not peered? What can talk, what can't talk? You have remote users that need to access your VPC. Do you bring them on-prem to a VPN solution? Do you VPN them directly into your VPC? These are things that you have to think about if you have people that, you know, aren't in your office. They're at home, they work from Starbucks, they are on the road visiting clients and need to access data. How do you get them there? And then, of course, there's always the internet to VPC, the Egress portion of that. So if you have applications that you're serving up to your consumers in the marketplace, things like, you know, web front ends, if you've got a marketplace, you've got applications that people need to access, you need to figure out how you're going to control and get those people into your information, into your web devices. And then, of course, the main topic here is how do we take that information that you have on your boxes that need to get out to the internet? Because some people say you can't have an IGW in the cloud. Everything has to be routed back on-prem to get out to the cloud. That causes inherent problems around cost and some other natures. So we're going to talk about, you know, what are the different models to get out to the internet, whether that be centralized, distributed, whether that's using native services or bolt-on services. So that's kind of what we're going to cover. So let's take a quick look at the background of VPC egress traffic. So why does this matter to companies? Why does your environment need to get out to the internet? So you have apps that you deploy in the cloud. They need to be able to reach the internet for various different reasons, whether it be API calls, Amazon services. You want to reach out to Office 365, and I have a slide coming up that kind of lists some of the items that we currently see that people get out to. You need to make sure that you don't have access to places you don't need to go. When you look at moving into the cloud, it is a compute environment. It's not your personal laptop. It's not your desktop machine. These are very predictable workloads. So you don't want somebody to be able to jump onto a server and then go someplace they're not supposed to go. The other big thing we see is hairpinning of traffic, which I kind of talked about a little bit earlier, is, you know, everybody wants to route traffic back on-prem because that's where most people are comfortable with. When you look at network and security teams, they've lived in the on-premise data center world since the beginning of time. That's how they did business. They want to touch and play with little devices that are plugged in. They have complete control over them. They own them. They know exactly what they do. So everybody just tries to send data back on-prem. And then for a lot of clients that I deal with, they have regulatory issues, whether it be PCI, HIPAA. They need to control traffic where it has to go. They need to know exactly where it's going and why it's going there. So what does Amazon do for you today? So Amazon has NAT gateways, they have NAT service, they have NAT instance. When you look at these items, they provide a feature which is basically access out. As we talked about in the shared security model that Amazon has, we'll tell you that you can open the door. We're not going to tell you who can go through the door. We'll give you the keys, let you go, but we're not going to lock it down for you. That's entirely up to you. They do give you some ways to do that. And a lot of that is around EC2 policies. So you have security policies and security groups that get assigned to your EC2 instance, and you'll lock them down by IP addresses only. So you can't say, I want to be able to get access to Microsoft.com. You're going to have to list those IP addresses for Microsoft.com in order to allow them to go outbound. Now, there are some inherent limitations that I will cover in another slide. So we talked about, why is it leaving? So here's some of the examples that we see clients, they have Office 365, the Salesforce. They may need to reach out to a third-party external site. Maybe if they're a financial institution, they need to reach out to Bloomberg or some other place that that device has to get access to, and they want their services to only go to that device. They don't want you to be able to get out and go to Google or Yahoo. You have your server updates, Ubuntu, Red Hat, you've got Microsoft. They all have patches and software downloads that you need to gain access to. How do you understand and manage all of those IP addresses? And what happens if they change that IP address because it's tied to a DNS name because they have an outage or something? Now you may not be able to get back out. And then of course, in Amazon, Amazon does have public services that are not accessible via an endpoint, which you'll need to go outside the outbound internet access to gain access to those items. So if we look at NAT and what Amazon gives you, it's all IP based like we talked about. There's no FQDN. You just can't roll into your security group and type in Microsoft.com, give it a port number and tell it you want it to go somewhere because it has no idea where to go. It wants you to place in 8.8.8.8 if you want to go to Google to be able to reach DNS. And this is all controlled by security groups. Security groups do have hard limits. So you get roughly 5 security groups with a limit of 50 rules per security group. That can be sliced and diced. You could do 2 by 125 if you want, but that hard limit is by account and by interface. So what are some common architectures for egress control? The first thing we're going to look at, there's basically 3 of them. The first thing we're going to look at is what is NAT? It has very limited capabilities. It's tied to your VPCs. So it's a distributed architecture model because every VPC egresses from their own location. That's all IP-based security controls like we talked about. So it's very limited in what you can do. So if we look at centralized, you'll see that you'll find people that will deploy some type of firewall in a security service VPC to allow you to gain access out to the building. This does give you full functionality. There are plenty of firewall providers in the marketplace that allow you to do this design and architecture. They do have inherent costs because now you're paying for full-blown firewalls and maybe you only want a piece of that firewall. And then you also have to look at, now I'm traversing outside of my VPC, so you may have extra internet-bound cost leaving that VPC to go to your security VPC to go out to the internet, that some people may not know how much traffic is going out to the internet. And then you have what we call inline or distributed execution with full functionality. And this is kind of where Aviatrix plays. And this is one of our offerings that we have as far as use cases where you get a device deployed in each VPC that you can control access to go out to the internet. So when we look at VPC egress security, there's basically 3 main things that you need to think about. Discovery. When you have developers or you have people that have access to spin up servers at will, there's no more putting in a request to get a server and pointing it at your proxy box. They can just log into their Amazon console, fire up a machine. How do you know where they're going? You don't have that visibility inside of a a NAT gateway or a NAT instance, you're going to have an outbound security group rule that says 0.0.0 goes to, it's allowed out. And then my route says I go out to the internet gateway and off I go. You have no idea where your people have gone. And that kind of rolls into number 2 is security policy controls. How do I lock that down where I can understand it and be able to make sure that I'm locking down what is needed based on what I've discovered versus what's not needed. And then of course there's cost. So when you look at cost, NAT gateways that come from Amazon, you pay a charge per hourly rate for that NAT service to be able to gain access to the internet from your private subnets. They also charge you what's processed through that box. So you have an inherent cost to get out to the internet. What some people don't know is that if you look at the Aviatrix product, we do offer NAT as a service to get out through our gateways. That's a free service. We don't charge for that. So we can take over your NAT gateway and allow you to get out of the building. On top of that, though, we do give you the ability to start doing policy-based controls. And our hope is that we're going to save you some money, and then you're going to pay us some money, and off you go. You get your policies, your security controls, and other items, and you're able to manage that cost and look at it from a holistic piece. So let's talk about VPC traffic to the internet. We talked about why it matters. You don't know what's going, right? You don't have visibility into the product. And how do you demonstrate compliance through reporting? That's some things you cannot do today. So this kind of gets into what we just talked about. You know, it doesn't provide items at a domain name level. Everything we talked about in a security group and most of the items that are listed inside of Amazon's platform are all IP based. Even if you're blocking ports and protocols between VPCs, it's all at an IP address level or a CIDR level in between those two devices. So what's missing in those is what Aviatrix can fill the gap with. And that's an easy way to view egress traffic at a domain name level. So when you look at the report or you pull up your tag that I'll show you in a demo later on, that you can see exactly where you're going. So if we look at security policy controls, there's some unique things about policy-based outbound traffic in the cloud. Egress can cause contention because it's typically a firewall state where we don't compete with a firewall. We are complementary to firewalls, and there's some other items that I'll show you in another slide that will talk about how we integrate with firewalls to do some other features outside of just our egress. So when you think, you know, security controls, you look at on-prem firewalls, they deal with all workloads that are in your data center. They deal with user traffic, you know, can they get out to the bad sites? Can they get to where they need to go? Can they access the information inside the company? As I mentioned earlier, VPCs and apps that run in the cloud are very predictable workloads. You know that if I have a VPC with 100 Windows boxes in it, I know they have to go get Windows updates from somewhere, whether that may be an internal Microsoft update server that you are monitoring what updates are pushed out to your environment, or you give them the ability to go out to Microsoft, and when Microsoft says, hey, something's wrong, go get my update, you go deal with it. So you're dealing with a finite list of where you need to go versus having it open for anybody to be able to search the internet how they feel necessary. And most of the time in the cloud, if you're dealing with instances, you may not need full deep packet inspection. There are certain environments that you're going to be required by regulatory controls to do deep packet inspection, but your DevOps guys and those items, you know, you want to control where they go, but they don't necessarily need to have their environment looked at for malware and some other items. So why can't you filter using an IP address? As we talked about, Microsoft, Amazon, all the big companies, they register their IP addresses with their domain names. So if for some reason they lose a box, it just reroutes you somewhere else because there's a list of IP addresses behind that domain name. When we talk about security groups, we're putting in actual IP addresses into those lists. And as I called out, that's a hard limit of 250 per interface. I'm pretty sure that Microsoft and Amazon combined have more than 250 IP addresses for their backend infrastructure that you would need to access to gain to, you know, your Microsoft updates. So the domain name will never change. The IP address behind it will. And that's extremely hard to manage when you're in an infrastructure that is fluctuating and scaling as fast as the cloud has gone today. So other considerations, you have VDI workloads that may be running. You're going to possibly need full firewall capabilities for that. You need out-of-the-box integration with logging tools. A lot of companies use things like Splunk, CloudWatch, Sumo Logic, Datadog. How do you get your egress logs into those devices from an Amazon-controlled service where you have no visibility? And then how do you prevent performance bottlenecks depending on your architecture? So we get into the whole managing cost thing. I am an architect. I don't really do cost, but we're going to cover this slide. So cost, if you look at AWS instance charges, your traditional firewalls, they need power. They came from an on-prem environment where if you wanted a 10 gig encrypted router, you go out and you buy a $200,000 device. Or if you just want to plug something up, you go get something smaller. That's the mentality that you have with, you look at virtual firewalls and other items. They've taken that same code that's built on purpose-built hardware, and now they've shifted it into the cloud. So now we have to find an instance size that matches the performance for that product to get it to do what you want it to do. Those can be inherently large and very costly. Then if you look at data charges, if you have centralized, like we talked about, you're getting charged twice. You're going to leave your VPC to go down to your security VPC, and then you're going to get charged again to leave that security VPC to go out to the internet. So you also have license charges. If you're looking at, various well-known firewall vendors, you're buying a product that maybe you only want egress. I don't need the other 55,000 things that the product does. And then you have, of course, your operational cost. If you look at the VPC to data center ratio, they say it's 100 to 1. When you're looking at that type of environment, it requires some type of centralized management. You can't manage 100 security groups for 100 machines with all different IP address schemes. It's really hard to do. And I've had clients in the field that they'll build egress-based platforms, and just the operational man hours it takes for them to manage, 200 or 300 machines running inside of Amazon that all have IP-based route tables and security group routes. It's quite time consuming because every time something changes, they now have to go update that in a bunch of different items, or they have nested security groups, and the list can go on when it gets to operational cost. So if we look at our solution, the Aviatrix solution comes in two pieces. You have an Aviatrix controller, which is your centralized management single pane of glass infrastructure. We then drop the gateways into each of the VPCs. If you're using this solution for egress, as I said, we replace the NAT gateway, so you no longer have that cost. And if you're just doing egress, we wrap that into our product. It's free of charge until you start building policies, so it gives you a chance to get used to our platform and see what you need to limit, and then you can turn those features on, and you're not charged until you turn that feature on. So in the next slide, I'm going to talk a little bit about our overall solution, because we do have different use cases that fit within our product, and all of our products are all encompassing. When you deploy a gateway, you have all the ability of our use cases inside of the environment once you deploy that controller and start deploying those gateways. So if you look at the solution, we said we have a controller, and then we have some gateways, and then we are a native plus architecture. So we integrate natively with Amazon, and we've worked in conjunction with them to deploy certain features and functionality. The first of that feature is our next-gen transit. This allows you to build connections from your data center or your branch offices into your Amazon environment in a secure manner. Then the topic of today's discussion is egress security. That comes built into our product as well. We then also have site to clouds. A lot of people deploy firewalls or other items, and they're building independent site to cloud tunnels to maybe a third-party provider where they need to do exclusive communication with maybe a financial institution or other items. We allow you to do that natively from our product as well. We also now have the Transit DNZ. We kind of talked about earlier that we have features that allow you to incorporate a firewall for all those other deep packet inspections and some of those other items that you want. We put that in line, and we are firewall vendor agnostic. So you can shim firewall of your choice or in between of our products, so that way you have access. We also have user VPN. You know, when we talked about those 5 things that kind of roll into the cloud for security, we have the ability to do a user VPN product directly in ours. And then of course we are a multi-cloud platform. So what we do in Amazon, we also do in Azure, and we also do in Google. So with that being said, we have a platform that gives you simplicity for multi-counter management and cloud management. It's all in a single pane of glass. We have amazing technical support. I get to work with these guys on a daily basis, and it's all as a pay-as-you-go model. So there's no upfront cost unless you choose to have that model. So if we look at some of the things that we compare to, people and organizations have things like a Squid environment, or they have, you know, other platforms. I convert a lot of clients from Squid. And so if we look at how we compare to Squid, you know, if you look at the HTTP and FQDN filters, they both do that. They both will give you HTTPS and FQDN. But if you have egress requirements for non-HTTPS, there's things that, you know, other providers like Squid does not do. So you can't go in and put an egress rule for, you know, SFTP, or if you need an egress to an SSH port. We do offer multi-AZ, so it is a load balanced environment. So you can deploy a egress control gateway into 2 AZs, so you have redundant failover. We are centrally managed. We do offer security. We are a full RESTful API product, so you can integrate directly with our APIs to build custom items. So if you have something like maybe a, let's see, what's a good one to use? If you're using like ServiceNow and you want to build automation workflow to allow access out, so maybe somebody is asking for a VPC for a specific group, and you have an automated workflow that will automatically build and apply a policy to that, you can do that directly for an API. We are a Terraform supported product, so all the DevOps guys like to do coding. You can use Terraform to go directly into our product and deploy gateways, transit VPCs. We also have out-of-box logging and integration. And we are a supported product. We do have tech support. It comes with the product when you download it and get it from the marketplace. You have base level support, which is 9 to 5, Monday through Friday. And you can also do platinum support if you choose. So I'm going to pause my screen for 1 second here while we switch into a demo. And I'm actually going to go through the product for a little bit and show you what our security screens look like, and what you can do, how you can look at discovery, and how you can actually apply tags to limit outbound activity. So what you'll see here is our Aviatrix Cloud Controller. The Cloud Controller is running inside of your VPC. You own the environment. So when you first log in, you come up to a dashboard. Anything that you may have running in the environment, you'll see here on this first screen. If you have any types of our other items running, like peering, you'll see your connections. If we look over here on the left, you'll see that we have a security tab. There's some things that we can do with stateful firewall. So the stateful firewall piece is where we handle IP-based management. So if you need to create a policy and a tag and you want to actually do outbound controls, you can click on and edit it. And you can see here that I can go in and I can do source, destination, protocol, port range, and what I want to have done with it. If it's going to be allow all, deny all. This is how we handle tagging of IP-based items. And it's all done from a manual platform. So that way, once I have my policy built, I can then apply my tags to it and then apply it to a device. The other item, you know, which is pretty much our bread and butter, is the egress control for FQDNs. So if we looked at the 3 items when we talked about discovery, security policies, and managing cost, here's the discovery feature. So you deploy a gateway into your VPC and say you don't know where your guys are going. You don't have any clue what sites your DevOps people need. They've deployed this, they've built a product, and now it needs to get moved into production. And you don't know what they need access to in the outside world. So if you have a gateway that is running in discovery mode, and you basically do that just by clicking on this and hitting start, it'll put the gateway in discovery mode. We give you an option here to show what's been run through that gateway. So if I click on show, we're gonna go out and query that log. And on the right-hand side of the screen, it's gonna pull up basically every FQDN that this box has touched. So you'll see that there's 197 visited sites from Amazon to Microsoft. So now that I have this list, now what can I do with this list? So we make it so you don't have to actually go type all this information in. I can hit this little download button here. And when I download this device, it's actually going to give me a text file that I can then look at and modify and import into a tag that I can apply to a gateway. So if you look over here and I just pop this up, you'll see that I give it to you in a clear text file. So you can now go in here and modify this. So if we don't want to do logs at Amazon.aws, I can remove that. I can save it. And once I save that, I can then go down here and go to a new tag, and I can give this a name, and we can call this webinar. And now that I have this webinar tag, I can go edit this tag. So I can either add a new device, or I can say, you know what, I want to import what I just did. So I can now go here, and it's going to fill this list in for me. So now I have everything that's already there. And if you notice, I removed the Toronto item that was up top. It allowed me to delete that and then pull in what I wanted to. So I have all of this now in here. I don't have to manually type anything. I can then go all the way to the bottom. Oh, I picked a big one. And I can choose update. Now that I've applied that list of FQDNs to the device, I can then go down here. If I close this, I can find my webinar tag, and then I can attach this to a gateway. So I'm going to say I want to apply this to my training VPC. I click OK. So we have built-in error checking and auditing. So we don't let you do something that, so if you already have something running in Discovery, it says, hey, you know what? I'm already using this product. So I can't apply this because you still have me in Discovery. You still have me in learning mode. So we don't let you do certain things, which keeps you from stepping on your feet. So now I can attach this gateway. And I'm going to choose California, and I'm going to click OK. Oh, it's still, I did stop it. All right. Oh, my fault. Stop the wrong one. Click OK. All right. Here we go. I like doing things live. Here we go. Stop that. And then my webinar, I'll attach. And my gateway is C training. All right. So. I'm on a little big screen here. All right. So once this is tagged, you can look at gateways. You can look at any one of the gateways here. Oh, I attach this to a gateway. This gateway, here you go. All right. I have many gateways that I can attach because I've got stuff attached to it and running. So what you can do is once you've done it, you whitelist it. I can enable it. Once it's enabled, I've enforced that policy. If we talk about looking at, logging and other items, so I have this wonderful environment that I'm now securing and controlling egress control. And I look at, I want to log something, I can always go down to my settings and I can set up my log platforms. So I can enable Splunk or Logstash to kick your logs out. And by doing that, I then get a cool little dashboard. We are a Splunk team here. So if I look at Splunk, I will see my security tab. And so if I look at the security environment, it's going to show me accepted domain names. It's going to show me FQDN block names, so I can look at environments and understand what's been done in the environment. If I've blocked something that I don't need to block, I can see how many people have tried to go out to that site. And then I can also go down here and get other logs as well. Everything that I've talked about and kind of shown you today is all covered on our docs.aviatrix.com site. This is our how-to guide environment. It walks you through everything you could possibly want to know about our product. If you want to set up egress security, you want to understand what a tag means inside of the environment, you can always click on info and it's going to bring you back to this environment. So back to this. Oh, I don't know what started from there. Oh. And then it kicked me all the way back to the front. Wonderful. Oh, there we go. So, Alan, do you want to open this back up to question and answer?
Sure, absolutely. Joe, first of all, before we do, just a word of thanks. You know, we get a lot of different webinars here, and a lot of them are marketing speak, and a lot of them are, you know, good technical people giving explanations. But when we can get a real demo and we can really kind of dig in a little bit and take a look under the covers at how something works, it's the kind of stuff that our audience likes. So thank you so much for doing that for us. Appreciate it, obviously. And let's jump to questions, okay?
All right.
So, does the Aviatrix Solution support Terraform?
Yes, it does. So let me just kick out of this and I can show this to team. So if we go here to the docs.aviatrix.com site, if you look under Terraform, there is a whole list on the items that we do for Terraform. So you have Terraform tutorial. We list out our provider and how to set it up. We have a GitHub repository, so you can go out and look at the GitHub examples and build your own Terraform.
Cool. Okay. Next, how does the Aviatrix egress filtering compare, you know, to proxies in open source, such as like a Squid proxy?
So we covered some of that in the slide deck. You know, when you look at some of the other open source platforms, they are open source for a reason. They're built, there's no support. So if you get stuck, you're kind of on your own. You have to modify code. So with Aviatrix, you know, we are a purpose-built platform for the cloud to do networking and security for the infrastructure. So you get, with Aviatrix, you get that centralized pane of glass. You get the ability to do everything either in an API or in a Terraform script, and you get support. So that's kind of how we set ourselves apart from what you get from an open source proxy.
Excellent. Joe, next question comes from Jim. I see I guess it means I see TGW under the covers. Is this currently in use for the solution? If so, if yes, is it HIPAA or FedRAMP approved yet?
So we have the Amazon Transit Gateway. We do have a TGW orchestrator. So we are a bolt-on for that platform that allows you to build orchestration layers. I personally do not know if Amazon has gotten the TGW under HIPAA compliance or FedRAMP yet. That is something that would be under Amazon's control, since that is their underlying networking infrastructure they're using to tie VPCs together. It does not have encryption at the moment, so I doubt it would make HIPAA compliance because it's not IPsec tunnels to and from your VPCs. It's basically just an attachment on Amazon's backbone, almost like a PCX peer.
Got it. Got it. All right, let's go to the next one. Can Can I allow a whitelist at the region level, such as like all egress traffic to the US is allowed, for instance?
Yes, you can do region-specific items. So if you wanted to lock down your infrastructure to say you can only touch the Amazon US platforms, you can do a star.us-east.amazonaws.com, and that's going to say anything that's in US East you can access. You won't be able to get to any URL or FQDN that has US West in it because you've blocked that portion.
Got it. Excellent. Got a few more here. People writing in now. I always wait till the end. I'm sorry. What activities for the traffic filtering are logged, and how do I export the log files?
All right. So in the demo in the cloud controller, we talked about logging here. So we log the FQDNs, we log the source that went out, we log the port information. That's all configured within the settings logging section. If you wanted to use Splunk, you would download the Aviatrix Splunk app, which is what I demoed in this section that shows you what the accepted domains were, how much traffic went out to that domain, what domains were blocked, how much of that traffic was blocked, the time that it went out, the number of gateways that tried to access it, source destination IP. We also have the ability to, from inside the environment, to look at the logs here. So you could look at a device and then download the log and view the log as well directly from the controller.
Excellent. Are there limits on the number of policies or rules that can be applied for egress?
No. So you can make your policies as big as you want. We just recommend that we store policies inside the gateways. So we just have to make sure the gateway is sized so it doesn't run out of memory.
Great. All right, let me ask you to put on your comparative hat here, and be honest, Joe. How does Aviatrix compare with AWS IGW or with ASG/ELB instead of for a NAT gateway?
Okay, so Aviatrix is riding inside of your VPC, so you must have an IGW attached to your device if you're going outbound to the internet. That is your internet gateway. So we run inside of the infrastructure, and then our routes in the route table for the outbound access for this device is pointed to the IGW. So you can go through just almost like the NAT gateway. If you look at application load balancers and elastic load balancers, those are typically built from what I've been dealing with, they're all inbound. So if you wanted to put items behind a load balancer, so we really don't play in that space. We have our ability to do high availability AZ egress, and our gateways can run in an HA mode, but we're technically not an application or elastic load balancer.
Excellent. Good. Great explanation. Good work, Joe. Next question, Elizabeth wants to know, what version do you guys currently use? I guess you might be talking about TGW.
I'm not sure. That is, can we let Elizabeth speak? Maybe she can ask what version she's talking about. Is she talking about the version of our product, or?
I think it's TGW, but Elizabeth, if you wouldn't mind asking, what are you referring to when you talk about version? Is it TGW or something else? You could pop it right in the question section, Elizabeth. We're watching. While Elizabeth is doing that, Joe, let me hop to another one. What throughput is supported for your egress solution?
So our egress based on our gateways are based on the size of the gateway. So if we go back to the docs page here and we look at, actually I'll do it the easy way. We just go to gateways and we'll look at the sizing here. So that's based on the gateway size and how much information it can process. So as you know, Amazon has different EC2 sizes. So we are an actual physical Amazon AMI instance running inside of a subnet in your VPC. So we can pass traffic based on the instance size. So if we look at EC2, There's so many. Trying to give you guys a place to look. So it's not in the screen. Oh, let's see. It's actually in one of the startup guides here. So basically, if you have a T2 micro, that'll burst at literally, I think, up to 130 megabits per second. That is limited by the EC2 instance size. So if you wanted to try and increase your throughput and increase the number of items and number of machines that can go out, you would increase your EC2 instance size in order to garner that change. And that can be done on the fly, non-disruptively. So inside the controllers, you have the ability to edit a controller, and then you can actually resize the gateway on the fly. So I could pick a gateway, choose the size, and then update it.
Fantastic. By the way, excuse me, Joseph, Elizabeth wrote, it was TGW, and she got her answer. But we got another question. We got a lot of questions here. Are there any troubleshooting tools that Aviatrix provides?
Yes, there is. So we have the ability to troubleshoot our gateways. So let me just go back into the demo. That's probably the easiest way to show that to you. So inside of here, if we look under troubleshoot, so inside of this, we have the ability to do logs. We can do diagnostics at the network level. So we can troubleshoot directly from our gateway. So as you build your infrastructure, there's no need to launch or build a bastion host to do a trace route test. Once you deploy the gateway, it is a running EC2 instance. So you can then do a network connectivity test. You can choose port protocols. You can run your packet captures directly from our gateway and drop it out to the internet. One of the coolest tools we have for troubleshooting, I feel, is our flight path tool. So if you look at flight path, when you look at troubleshooting inside of Amazon, connectivity inside of Amazon is a plethora of different things. It is security groups, it's route tables, it's NACLs. And if you're comparing VPCs or accounts, you have to have both accounts open, multiple screens. You're doing screen captures. I can easily go here and I can pick an account name. I can pick a region. I can pick a VPC. I can query that. I can pick a different account. I can pick that information. I can look at the VPC. I can query it and find the resource that I'm looking for. And once I've done that, oh, there's nothing in that one. So I'll query this resource, and then I can pick, say, my Virginia DevOps server over here. And I want to be able to see why I can't talk to my GT3 box. So, and I want them to say this is private, and I'm going to do ICMP. So we'll just do HTTP, we'll do TCP. And I would say I want to do port 443. I hit flight path test. What this will do is this is going to run in the backend Amazon API calls to go gather this information for us, and it's going to display it for you. So that way you can get a very quick visual representation of what could be wrong. Maybe you have a route table that's missing a route entry. Maybe you don't have a PCX connection between your two VPCs. So.
Got it. Got it. Then the other thing is, how can we control egress rules by source IP address?
Source, so when you say control, so basically outbound, what devices can go outbound to the internet via a source IP. That's done under the stateful firewall rule. So it's attached by the gateway. So if I say these are my DevOps tools, and I want to look at the policy for, say, the ARN demo device, I can say I have a policy and a tag that has, you know, here's my source. My destination is going to be, you know, a private IP address to an outbound environment. So maybe it's, or a public IP address. So maybe you're going to a specific company and you only want to let this single machine out using a specific port. You would do that directly in this screen.
Excellent. Good stuff, Joe. We're getting to the end here. Also, I should note, look, we just sent out in the chat window to all attendees a link with some really good a fact and some really good background information. So if you can handle that. Last question for you right now, Joe, unless something else comes up. How does Aviatrix solve for resiliency within a singular VPC including spread across multiple AZs?
I'm going to take that this question is in regards to egress in our gateways. So our gateways are able to be deployed in an HA fashion. So you can deploy a gateway in, say, AZA if you're in US East 1, and AZC or AZD. So you'll have redundant gateways. If those gateways are then active with inside of their respective AZ, if you have a failure for AZA, the gateway goes down, something happens to the EC2 instance, Amazon has a hiccup, all your traffic will get failed over to the other running instance that is running in the other AZ, so it will not disrupt your internet traffic. As our, there you go. You there?
Got it.
Okay.
Oh, I realize you're waiting on me, Joe. I apologize. Yes, we see the picture. All righty. Hey, Joe, again, fantastic job, man. We appreciate your time and expertise, and you really did a nice job of explaining and showing a little bit under the covers here, and it's much appreciated. Obviously, for more questions or more, you want to find out more, you can look here. We have a couple of links for you, some email. Take advantage of it. Great presentation, guys. I did want to quickly announce the 5 winners of our Amazon gift cards. They're $50 each, and they'll be emailed to our winners. The winners for today's Amazon cards are Lance Kelson, Mohammed El Ghafi. If I mispronounce names, I apologize. Ray Figueroa, Elizabeth Cray, one of our questioners, and Giorgio Peroni. So thanks to the 5 of you. Congratulations. Spend your Amazon gift card money well. And remember, we do give them out for every DevOps.com Security Boulevard webinar. So if you stay till the end, you can win some money. But that's not the only reason to attend. Learning stuff like we did today with Joseph and the folks at Aviatrix is the real reason. Thank you all very much. Special thank you to Aviatrix for sponsoring today, and a big special thanks to Joseph for presenting. This is Alan Schemmel for DevOps.com Media Ops. We'll see you soon on another day, on another webinar. Have a great day, everyone. Bye-bye.